Welcome to your second video, class A students. Today we will proceed your factorization process, factorization chapter into more detail, and we will apply some identities also. So you know identities, you know a plus b whole square equal to a square plus 2ab plus b square. Okay, you know it. Another a minus b whole square equal to a square minus 2ab plus b square. A square minus b square, a plus b into a minus b. Or if it is in this form, you can write this form. Okay, so we have to learn by heart these three common identity. Based on this identity, first we have to know the question which identity will be applied here, or which common form the question lies to have the similarity with the identity. Let's go with the example. Suppose an example, a square plus 8a plus 16. Factorize this one. Okay, so first think which identity will be applied here. This seems to be a square and this seems to be a square, and all are positive. So compare these three identity and guess which one will be more appropriate for this condition or for these terms. It looks like this one fits more properly because square form is there, another square form is also there. This is 4 square, and it looks like it may be fit to the form 2ab. Okay, let's proceed. This is the a square and this is the b square. 4 square, 16 is a perfect square of 4. So let's do with 2ab form. 2 into a is how much? Whatever inside the bracket, that is a, and whatever inside the bracket here is b. b means 4. A is a itself and b is 4. So just write 2ab, 2 into a into b. A is a, that's why I am writing a here, and b is 4. Now do this multiplication and check whether it will be 8a or not. 2 into a into 4, 8a. So it fits the identity. So we can proceed further. Now I can write, if this is in this form, I can write a plus b whole square, a plus b whole square. That means a plus b is how much? 4. A plus 4 whole square. You can write a plus 4 into a plus 4. These are the factors. So a square is a into a. It means a plus b whole square is a plus b 4 into a plus 4. Let's go. Let's solve another problem, another example. 4x square minus 8x plus 4. Okay. So this can be a square. This can be a square also, having minus item here. Okay. So guess which form, which identity will be fit. Are you thinking this one fit? Okay, you are right, because here minus term is there. So let's check whether it will be 2ab or not. So 4x square will be which term square? What can I write inside bracket? 2x. 2 square 4, x square, x square. So you have to calculate which term you will put inside bracket. Okay. Now let's do the b square. Now we will check whether it will be 2ab or not. 2 according to identity. A is how much? A is 2x and b is 2. Okay. Always make clear which one is A and which one is B. Now do the product whether it will be 8x or not. Sorry, this will be minus here. 2 into 2 into 2, 8 into x. Yes, it is minus 8x. So I am going in the right path, and my guess for this identity is perfect or correct. Now I can write what? A minus b whole square. A is how much? 2x. And b is how much? 2. Because there is minus 2ab, here a minus b whole square will be there. And it will be 2x minus 2. Again 2x minus 2. So you can write answer here or like this also. Let's go with some more examples. Okay. So 1 to 1 b square plus 88 bc plus 116 c square. Suppose the question is like this. So which identity will be fit? What are you thinking? From these three, it looks like the first one will be fit, a plus b whole square. Let's check. So you have to memorize the perfect square of 1 from 1 to 20. So which number, whose square is 121? You have to speak all of a sudden. After asking, it will be 11 square. 11. So b, 11b square. 11b whole square. 11 square 121 and b square. B square. Now I will write here 4c whole square, because 16 is 4 square and c is c square. Now I have to check whether it will be 2ab or not. What is a? 11b. And what is b? 4c. Okay. So I am writing 2ab, 2 into a into b. Now do the multiplication. 11 2 ja 22, 22 4 ja 88 bc. Yes. It fits to this identity. Okay. So what can I write? I will write a plus b whole square. A is how much? A plus b. B is how much? 4c whole square. Okay. So this is the factor. You can write also 11b plus 4c into 11b plus 4c like this in two terms. Okay. Let's go with more examples. Okay. Let's do a4 plus 2a square b square plus b4. Okay. So, is it in this form? Let's check. a4 is, whose square is a4? You can see. Can I make it a perfect square of one term? Yes. It is a square whole square. Okay. You can do it because having two exponent, it will be multiplied to each other. So a square whole square a4. Similarly, b square whole square of b square is b4. Now we will write 2ab. Where here a is a square and b is b square. According to this identity, here a is a square and b is b square. So 2ab. In In place of a square is there. In place of b square is there. That's why I am writing 2ab like this. So is it equal to this? Yes, it is equal to this. Now I can write a is a square plus b whole square. This is the answer. Okay. Let's do some different type of problems regarding this identity. Number 4. Number 5. L plus m whole square minus 4ln. Okay. So this is something different. It looks like different type of terms. We do not fit any of these. Okay. It is not in this form. So what can I do? How to proceed? Think what your mind says. Let's solve this in its way. So a plus b whole square. Now let's write down the values of a plus b whole square. A square, this is a square, plus 2ab, 2ab plus b square, b square. I am writing this form into this type of expression. Again 4ln is there. So these two can be minimized. These two terms can be made one term. 2ln minus 4ln will be how much? L square minus 2ln, okay, plus m square. Plus 2 minus 4, minus 2. So plus 12m minus 4ln will be minus 12m. Now look, this looks like a identity form and it fits in this way because minus 12 is there. So this is L square, this is m square, and this is 2 into a into b. Okay, this expression fits to this identity. So I can write L minus m whole square. Okay, so from the beginning of the question, it does not look like that it fits any of the identities. But after proceeding and writing, expanding this one in this form, I got the path. Okay, let's solve another type of problem. 16x5. Suppose 16x5 let's do another. X square minus 2xy plus y square minus z square. Okay, it also looks like this. Let's go with simple one first. Suppose 6 will be, before solving 6, let's solve a simpler one. 9p square minus 4p square minus 9q square. So there are two terms is there, and in which form it will be fit? Guess from these three identities. It will fit to this identity because this is square form, it is square form, and there is no 2ab form. So whose square is 4p square? Who can say? 4 is 2 square, p square is square of p, 2p whole square. Here, who can say whose square will be 9q square? 3q. Okay. So this is in this form. A plus b whole square, a square minus b square. So I can write a plus b into a minus b. A is 2p and B is 3q. Okay, A plus B into A minus B. Okay, so in this way we will proceed now this one. Okay, let's proceed. This is a square. This is not square form, but we can make it a square form by this identity, using this identity. Yes, compare this one and this identity. A square, 2 square form and 1 2ab form. I am guessing, not I am confirm, but after checking I will get it. Okay, so first x whole square plus y whole square minus 2a into b. A is x, b is y. Okay, minus z whole square. So these 3 terms was not in a perfect square form. So in order to make it a perfect square form, I am expressed in this way. Okay, now I can write a square minus 2ab plus b square. A square minus 2ab plus b square. I can write a minus b whole square, a minus b whole square. Again, z square is there. Now see, in what identity it falls? A square minus b square. So in this expression, 2 identities are required. Here, a square, if it is combinedly taken as one unit, a square minus b square. Okay, so in this way I can write here a square minus b square. A is x minus y and b is z. A minus b into a, I am writing a here, plus b. Okay, because the identity says a square minus b square equal to a minus b into a plus b, or a plus b into a minus b. You can write first this one and this one, or this one and this one. You can write, if you make plus here, it will be minus here. Okay, both are right. So let's go with another example. Number 8. Number 8. 16 x5 minus 144 x cube. Okay. So think, in what form it goes, or it will fall, or it looks like fall. Okay. There is nothing to match with these 3 identities. Okay. So how to think, how to proceed? If after thinking a long time, or after thinking deeply, you do not know whether which identity will be fit, first of all there must be something common. Listen to me carefully. If there is no identity fitting to the expression given in the question, it means that there must be something common in the terms. So what is common here? You know that 16 is a square, 144 is a square. If there is common, 2 will be common here, but don't do that. Okay, because both are perfect square. Okay, so what will be common here? As the numerals are perfect square, we do not toss them, and we will take, it is not in perfect square, x5 or and x cube. So from x5 and x cube we will take something common. So from x5 and x cube, what will be the common term? x into x into x into x into x, x5, x into x into x, x3. So x3 can be taken because here 5x is multiplied, here 3x is multiplied. In both of them 3x is there in multiplied form. So x cube can be taken as 16 into x into x into x into x into x minus 144 into x into x into x. Okay, so what is common? 3x, 3x. 3x means 3x multiplied, it becomes x cube. So let's x cube will be, let's take x cube as common. Here 16x square and 144 x square. 144. Okay. If x cube is taken common, what will be remaining? X into x, x square. If x cube is taken, what will be remaining? 144. Okay. So let it be there till the end. X cube will be remaining as x cube. We have to factorize this one only. So whose square is 16x square? 4x. And whose square is 144? 12. You have to memorize it. Okay. Now proceed. So we can't do anything to x cube, or you can write x into x into x. So let it x cube only. So I can write a square minus b square. I can write in this form. A is how much? 4x, and b is how much? 12. Okay. So 4x minus 12 into 4x plus 12. Okay. So x cube is there. Okay. So this can be again factorized because 4 is there to take common. If there is something going common, always take common. Okay. 4x minus 12 is not in a simpler form of factorization because more factors are being taken, can be taken from this expression. So I am writing here 4 can be taken. How much? X minus 3. Okay. Yes, 4 is x, 4 into x, here 4 into 3. So if 4 will be taken here see 4x minus 12, 4 into x minus 4 into 3. So if I will take 4 common, here it will be x, it will be 3. So I am writing x minus 3. Could you follow this one? Similarly, here I can write 4 into x plus 3. Okay. So how much? 4 into 4, 16 x cube into x minus 3 into x plus 3. Okay. If you have taken from the beginning 16 x cube, then also it will be, and it also makes you more shorter to reach this one. Let's go in that way. If you like that way, you can proceed also in that way. 16 x5 minus 144 x cube. Okay. So what can be taken? 2 into 2 into 2 into 2 into x into x into x into x into x minus 2 into 7, 2, 36, 2, 18, 2, 9, 3, 3 x into x into x. Okay. Okay. So what are common? Here 4 2's are there. Here also 4 2's are there. So 16 can be taken common. 3x are there, 3x are there. So x cube can be taken. Okay. So write down 16x cube from this one. Here x square is remaining part. Here 9 is remaining part. Okay. So this can be converted into a square minus b square because 3 is a square, and we can put this identity here. Okay. So 16x cube into x whole square minus 3 whole square. Okay. 16x cube is a square minus b square, a plus b into a minus b. This is also a process, but something shorter than this one. So you can prepare this process, also this process. Okay. For this video, this is the end. We will discuss new identities and with new questions that are solving through new identities in our next video.